These are probably the most fun things you can do for those that are leaving. You're going to miss out on what I think is going to be probably a hallmark of this event. These are unscripted, which I love because you're going to get honest answers from people who are asked low latency questions. Trust me, this is going to be a good panel. I'd like to start the panel by, and this is echoing, so I may request that microphone again, just because this is not sounding well. But I'd like to start with Dave on the end, and then just run to Jim, and then Kevin on sort of what their companies are doing. This really is going to get kind of deep, a little bit technical, but please, quick intros while I fix this.
Sure. So good morning, everybody. I'm Dave Johnson. As George mentioned, I'm head of the IT division, and that group inside Schneider takes care of everything Schneider does inside the data center. So Schneider overall is about a $30 billion company, global leader in energy management and automation, but our division takes care of data centers. So, and we operate in DCD language, maybe mostly south of the rack, George, so, but up to and including the rack. So we do power and cooling. We're also one of the leading vendors for enclosures and rack systems, though, globally. So we do go up to and including the rack. And that's who we are.
Jim? I'm still Jim Fletcher, and still with Momenta, I hope. But no, so Momenta, the reason I liked joining Momenta after IBM was their focus around IoT and industrial IoT specifically, and really helping businesses transform from where they are today, both business transformation processes as well as growing their technologies through acquisitions or mergers or whatever else, and really just focusing on the IoT space and the growth of IoT. I'm passionate about IoT. It's gonna change everything we do, and I want to be part of it.
Yeah, my name's Kevin Kettler. I'm with Flex. I'm the CTO of our communications and enterprise compute business, which is the largest business within several different business units within Flex. Our main focus, the CEC business unit focus, is on the cloud compute infrastructure, edge compute, as well as optical and interconnect and networking for the industry. And then we also have a huge telco presence. For those that aren't familiar with Flex, we do both design and design services, as well as a significant amount of manufacturing worldwide for all these different areas. We have a pretty unique perspective in this, or I consider a pretty unique perspective, because my team is focused on a lot of the things near and dear to the heart of everybody in this room, but we also have several other teams that are doing everything from lighting controls, home controls, smart city, healthcare, the AR, VR units, textile and healthcare interactions, and autonomous vehicles. So the interesting part, that the role that I play is very interesting, because I get to see a lot of this stuff come into play and get folded on top of each other, and then the core of it is what my team's working on.
So, Kevin, you do have an interesting role in all of this. When I was speaking before, I talked about manipulating atoms versus bits. If there's a base station out there, chances are you make some component in that or the whole thing. If there's an open source initiative, you guys are involved on the design of those open source initiatives. If it's an enclosure, you can make enclosures. On the manipulating atoms side, how do you think that the convergence of the bit versus atom is going to play? What role does the bits have today versus what role they have tomorrow in context of the atoms you manipulate?
Well, as you've described earlier in your speech, there's a couple pieces that are coming together here. We do bend a lot of metal. We do a lot of plastics for people, for all the products we do. We are working down at the atom level for a lot of the pieces that come together. But by the same token, the the bit movement and handling how we're able to manipulate bits, move bits around is so crucial to how this all comes together. My talk later on today, one of the key areas that we're very focused on is 5G and how 5G will enable a lot of the pieces that are coming together. It's for Flex, at least as we look at this, it's a very important technology that allows us to go ahead and see that bit movement and the model around the bit movement change. I've got a few gray hairs, a few more than Cole does here. So I've seen, back in the early days back in the early days, you were dealing with very much a client-server approach to compute, and then we've moved to more of a cloud approach, and now we go back to a little bit more decentralized opportunity. Not that the cloud is going to be de-emphasized, it's just going to be an augmented piece to the cloud is where this edge computing comes from. So, and all of that is as I look at it, I always look at this stuff relative to economics, and the economics of how to go ahead and build the infrastructure to create these new business models, use case models, will define how this ultimately manifests itself in terms of the structures around bit movement.
I want to come back to economics and ask that specifically to Dave, but before we do, Jim, you talk a lot about IoT. Your presentation was all about IoT. I remember growing up, definitely less gray hair than Kevin, but I do remember growing up thinking that TV was ubiquitous. That was sort of my, on-demand. Before that, it was probably electric grids, right? And we all expect to walk into a room, flip the switch, and the energy's there. We take it for granted. It's completely ubiquitous. What do you think the role of software is in the ubiquity of the underlying infrastructure? So the experiences that we're going to get from AR, or the experiences we're going to get from all of the machine-to-machine communication that's being generated, how commoditized is the underlying world, and what expectations should software have of that hardware?
Yeah, so first off, I didn't know we were talking about gray hair today, but I forgot my Grecian formula this morning. But, kind of going back to your thing on atoms versus bits, if you watch things, pick whatever those things are, pick your television as an example, right? Back in the olden days, when you bought a TV, the day you bought it, it was the same TV the day you got rid of it. Pick most anything that you have today, it has the ability to transform itself based on new functionality. I actually saw a great slide from a lady that's in charge of IoT at Amazon at an event I was at last week, and she was talking about 10 years ago the type of entertainment system that was in her car. And she had a CD player and a plug, an RCA plug, right? And that was her entertainment system. If you think about today, I bought a new car a year ago, and it's already updated itself multiple times. And so what you're going to see, I think, is a move from more hardware-oriented physical things to software-driven managed things. And the expectation is going to be that they transform themselves on the fly. Where your challenge starts coming in is things like radios and things like that. So you're going to have to do software-defined radios, right? Because the radios are going to change instantaneously on you and the ability to do it. So, I'm a software guy, so software is by far the most important thing in the world. And I think you're going to see that happen, continue to grow in importance.
So this is great. This is why Dave and Jim are sitting next to each other. So, Dave, software is eating the world, or so says Mark Andreessen, right? How do you guys think about that versus the underlying critical environments and the underlying ruggedized environments that sit there and have to power all of these things? And what economics, what does the role of economics play in all of this?
Yeah, so it was fun to see Suresh's presentation this morning with all the electrical distribution and power equipment eliminated from the equation. That wasn't a fun future for us. But I mean, I think the reality is when we talk about, so we've been seeing in central data centers, we've been seeing the resilience sort of being pushed to the software layer for sure. So we don't deny that. The reality is you still need some level of resilience that's taken care of at the physical layer. So we've been adapting to that in the cloud, let's say, with all the growth with the hyperscale players, and even as they move into co-location data centers and the purpose-built data centers by the hyperscale players, they're all comprehending the ability to move resilience to the software layer. So we've been simplifying our architectures. That's going to be true at the edge also. But it's interesting, you put up your numbers going from 40 sites to 40,000 sites. When you start to think about downtime, if you think about that system going down, you're in a huge multiplicative effect now if you look at any one of those sites going down and losing service. So we actually see we see the edge happening, of course, big, just like everybody else. And the numbers should be huge, but it doesn't feel like it's quite here yet. But in those spaces, we see, if you look at a distributed IT application today, say in a retail store, traditionally pretty low resiliency level. Basic, might have a sort of a 1N backup, maybe not have adequate cooling. The future is going to be that's critical. That's going to be a physically secure environment. It's going to be maybe 2N resiliency. It's going to be cyber secure. It's going to be monitored remotely. And so the resiliency level we see at the edge going up. We've been dealing with the simplification of it in central data centers, but the resilience level is going up. In terms of the economics side of it, I mean, if we think about the future applications that we're talking about AR, VR, you're not going to get there without applications at the edge. If you try to serve this centrally, first of all, it's not going to work. And the cost of doing it would be prohibitive.
I want to talk a little bit about security because it's something you all brought up, and there are layers and levels of security that have to be solved for. I was trying to remember this, I think it was a very mediocre movie where the hackers took over a bunch of autonomous cars and then attacked another car. Mm-hmm. But to the TV point, there was actually a DDoS, mm-hmm. right, from this server chip. I'm not going to say which one, but it all used the same software, and TVs were hacked, and baby monitors were hacked, and denial of service was created against a few websites. What do we think? And Dave, we'll start with you. What do you think? And I like the awareness side of this. When we think about the title of this, we're talking about two things. If we were to drive the analogy of this next generation data center being sort of a human, right? Because we talk about artificial intelligence, and we talk about, you've got the nervous system, which is all the brainy software stuff, but you have a cardiovascular system, which is, keeps the blood pumping. On security, Dave, what do you think the hardware needs to do to enable these profile changes that happen for cloud security, data security, and the higher orders of security and software?
So, I mean, first of all, if you look at a car, if you look at a system, a lot of you were talking earlier about the ecosystem of providers. Everybody, even starting with Suresh, talked about creating this ecosystem to bring things together. So, first of all, everybody has to do their part on their individual bit and piece has to be up to the latest cybersecurity standards, right? But now we have to work together to create these systems that are cyber secure. What a challenge that is, right? I don't know if I have all the answers to that yet, but that's I think that's a big challenge ahead for all of us. Nobody can take care of the whole solution on their own, and so to me that's the first sort of the first order challenge.
Jim?
You hit it right there. It's your security is only as good as your weakest link in a lot of these things, and that's kind of one of the things I talked about was security is a last thought. People are trying to develop low cost, get to market quickly. It's kind of generation one of a lot of things today. To me, one of the key things with IoT is the physical awareness of where that thing is. And I use an analogy of a traffic light. A traffic light, if it were an IoT device, it's important to know where it is. It's also important to know what its current navigation is. You know, is it facing east and west or north and south? Because the information from it is exactly the same regardless of how it's positioned. But if somebody goes and moves at 90 degrees, it has a totally different meaning. And so the ability to spoof, there's a whole new set of use cases for spoofing now with IoT things that you've never thought about before. And so, you know, we've got to be careful that we don't get too far in front of ourselves and have a meltdown of some sorts that derails IoT for years to come. But we can't sit back and do nothing while we wait on security to catch up where we are. So it's kind of a real challenge here to do.
Yeah. So Carl Sagan, famous astronomer, says that the brain does more than just think, right? It synthesizes, it analyzes, it generates abstractions. Kevin, as Flex, when you guys are building all of this hardware and integrating with software, you guys have to think about both sides of the equation here. Mm-hmm. How do you think the world will respond when all of this data needs that contextualization in order to do intelligent things and from a security standpoint?
Well, that's a layered question. We kind of view it as there's a couple different layers for security. So there's one piece that we're always looking at, which is just physical security of assets. So you start to say, okay, if we're building a base station for a cell provider or carrier, there's physical security requirements around that we build into the design around that. At the next layer up, I'll start to talk about the physical hardware itself, and you say, are we building the right structures in the hardware to go ahead and enable you to put hooks in your software to know where you are, what your device is, using things like encryption keys and other things to go ahead and ensure that what it is that is coming from that device is known, understood, and coming from an authorized source. So there's a lot of hardware pieces that we build into, that silicon providers build in, and then we integrate together at the hardware level. And then you start to move into the software level and you say, what can we then do around encapsulating things, whether it's building robust containers and the ability to move software around easily and have it run on hardware and have that be a known environment that is controlled and understood and owned by whatever party is owning that software at a given point. So we tend to look at it as a layered approach. We've got various different layers. I think another thing that we're dealing with a lot of customers is around the notion of data protection. So I'll use this within data centers. We spend a lot of time talking about how do we ensure that data, no matter what state it's in, and when I say that, it's, let's say you've got a hard drive that is on a machine, the machine goes bad, you pull that machine, you replace it, the hard drive gets replicated, but what happens to that old hard drive? How is that managed? How is that handled, tracked, taken care of, and ensured that the data on that hard drive is disposed of properly and there's no way to recreate or steal that data. So there's a lot of elements that we tend to deal with at different levels depending on the customer needs.
You know, well, so two things really quick. When I said before, Slido, apparently you do need sort of a context there. So hashtag DCD2017. If you want to ask questions, the hashtag for Slido is DCD2017. If you have questions for any of the panelists, I think we do. Second question, George, how are we doing on time? We're good. 10 minutes more. Good. So this might be a good time to bring this up. But before we get to the slides, actually, this is interesting. I remember, a lot of people don't know, Kevin and I both worked at Dell. And in my role at Dell, I sat on Novell's customer advisory board. In fact, you know, the entire factory ran on NetWare. and Dell paid ungodly amounts of money to support that. And we were trying to get off of it. In fact, we ran this project called Factory Infrastructure of the Future, and it was my project. And we were trying to work with Novell, who had just bought SUSE Linux. And I remember being on the customer advisory panel of Novell and trying to understand for the life of me why SUSE, after it was acquired by Novell, put libraries in different places. And they said, because it's differentiated. It's differentiated. Now, let's contextualize this. Let's fast forward to today, and a Cadillac has 5.9 gigahertz built into it, so it can do car-to-car, vehicle-to-vehicle communications. Audi is doing this in the United States right now. You saw the Audi to light post and traffic light integration. But an Audi cannot talk to a Cadillac, and a Cadillac cannot talk to an Audi. So how do we think about standards? It's been brought up a couple times here. How do we think about standards, and what roles should we as an industry be thinking about participating in versus are the governments going to have to come in and be a forcing function for us to communicate properly? What do you guys think? I'll just leave that one open.
I'll throw out some comments on, I absolutely agree with your comments on there will need to be standards, but the interesting discussions we have with a lot of our automotive customers have been around, as they look at building the infrastructure for their autonomous vehicles, you definitely have different tiers of investment associated with the vehicle. So as you described, the Cadillac, the Jaguar, the Rolls-Royce is going to spend probably a much larger portion of dollars on their autonomous infrastructure than what you might get out of a low-end car. A Yugo, I guess, would be they're not around anymore. But when you look at this class differentiation, there is not only the standards that you need to have this communication occur, but also the willingness in the business model. This goes back to the business model I alluded to earlier. Does the business model, is that put in place such that those car companies actually want to communicate with each other with the data that they have? Because a high-end car company might say, you know what, my data is more rich and more valuable than somebody that is spending 1/3 on their autonomous infrastructure on the car. So those two communicating, do you want your BMW data, or do you want your low-end car data to be the data that is considered relevant in making decisions? And so a lot of car companies are very protective of saying, I want my data to be exchanged on the class system of the car that I am actually making that investment around. So it ends up being a business model around some of that communication.
Someone's going to make a lot of money.
But some of this is going to be a balance between government and sort of market-driven. You're going to see, imagine buying a car that's sort of a closed platform, doesn't talk to other cars. My next option is buying a car that's open, it does talk to other cars. I may pick option B, right? Unless option 1 takes over the world, right? You also have, with edge, we've been talking about edge, so you have this ability, not vehicle to vehicle, but if the performance is good enough for whatever the communication is, I can go back and talk to the next point up the chain at the edge, if the speed is there. Yep. It gets rid of the problem.
Yep. Yeah, but if I look at this, why am I using a transportation or data transportation protocol as the limiter on whether my vehicle can communicate with another vehicle, right? Why am I not making the decision to go to more of a standard so I can communicate within one, and then I differentiate it at a different layer? And so I look at my house, again, at Z-Wave versus Zigbee, right? Left hand or right hand, right? Fundamentally, when I look at what they offer me about the same kinds of things, but they don't talk to each other, right? And so you've got this artificialness that doesn't need to be there. The challenge with standards, and we've always said this in the software world, is there are so many. And even getting the governments involved, if you look historically, how long did it take for cell phones to be able to interoperate worldwide, right? Because every government was involved, and every government worked with us in the industries to create a standard that was good for whatever company was working with that government. And so standards don't necessarily mean standards. Standards don't necessarily mean interoperability. Standards just mean standards. So I think we've got to look at this. And if I start looking at IoT and things around it, we really need to get to more of a worldwide kind of approach. Now, will that happen? Who knows?
Yep, I think that's right. You got GSM versus CDMA still.
Yeah.
So, Dave, going back, we'll jump into questions with about the 5 minutes we have left. And you said it can go one hop back and start making a decision. And there was a question, I don't see it on the screen anymore, but it said, will these edge networks with the latency, and let's just assume for a second that we trust what the 5G standard will be. So they're saying 5G standard, the latency round trip to the base station and back will be sub 3-ish milliseconds. So assume you're dark fiber connected, you're sub 5, maybe 6 milliseconds round trip to that hop. Is that fast enough?
It is, I think. It's coming close. We're talking a lot about driverless cars. That's kind of where it's a perfect place to test it. So somewhere around 4 or 5 milliseconds, you're talking about half a car length in terms of an accident. So you're getting in range where 98% of your situations are going to be taken care of. So it would be fast enough. The question is that good enough? I guess that's the moral question. Yep.
Anybody else? All right, let's keep going. What if the edge doesn't respond to a driving car? Should edge data centers be more resilient than the traditional ones? Now, I've got an interesting take on this, but I want to hear what you guys think as well.
Well, first of all, I think we've got to start thinking about resiliency different than we think about it in the past. I know one of the arguments I always had with my development team was what was disaster recovery, what was resiliency, what was redundancy. And we had different approaches for every one of those things. And if you look at kind of the modern compute world, I can solve all of those fundamentally at the software level with the same kinds of technologies. Now, it gets a little harder when I get over to power and things. I can't just do that dynamically. But I think from the software level, we're really moving to where these smaller units of work that are multiplied many, many times and work together, my beehive basically, those are small units of work all working together, and that solves a lot of these issues that you've got. Now, the other thing we talk about with edge, we keep thinking of edge as being somewhere out there. Edge can be in the cloud, right? There's nothing to prevent my edge being your cloud. And so if you take the concepts of edge, they can apply anywhere. They don't just have to apply to little things out in some closet somewhere.
This goes back to what George was saying this morning. Yeah. It's the contract that changes, right?
Yeah.
The edge is still a physical place in the world.
Right.
So that could be built by a cloud company, that could be built by an enterprise, or it could be built by a colo. Great.
I'll add a little bit to that.
Kevin.
In talking with the people doing the engines, the autonomous vehicle engines, the view that they have is they have to be, their view is they need to absolutely be able to make all decisions without need to interact with the edge. And that's their goal, that's their desire moving forward. And what they view the edge as is the edge will provide additional information that will just help direct some of the efforts that are going on. For example, a refrigerator falls off a truck. That information might be ahead in the traffic flow. Getting that back to an autonomous vehicle is information that's very localized. It's important information. But by the same token, if that information doesn't arrive, the folks making those engines, that are making the decisions, are also feel strongly that they absolutely need to be able to react to that situation without getting that feedback. And so it's one where the richness of information using the edge will be improved, the experiences will be improved, your ability to flow more freely, I guess, with an autonomous vehicle will be enhanced with the edge.
2 minutes, one question, two questions? Two questions. All right, two more questions. Let's see here. How do we work around the new form shape factors needed for the real edge? Now, before we ask the question, the real edge.
Is this your question?
I think this has been great.
It sounds like a Vapor I.O. question.
I'm not going to answer. But before we talk about the answer to the question that was asked, What is the real edge? Just take 30 seconds or less, each one of you, and what to you is the real edge?
So to me, the infrastructure Mason definition is a good one. It's an enclosure, a space, a facility located geographically dispersed, away from the core, and that takes a variety of form factors, right? It's a regional data center, it's a micro data center that can be in a factory floor or in a store, that type of thing.
All right, so being a software guy, I'm going to take a very different tack on it. And I'm going to say the edge is really not a physical thing. The edge is a logical thing. And the edge is an isolation of a set of work to accomplish a specific task. And the same physical box might be operating as an edge in one case, or it might be operating as a core in another.
Let me challenge.
Okay?
Beehives.
Yes.
Those forward deployed worker bees, would you not call the flower the edge? That's a physical thing. They're going and pollinating, yeah?
See, I was calling the flower kind of the other cloud, right? So, okay. Because if you think about in the case of a beehive, they're going out and getting data from somewhere else, and then while they're there, they're also exchanging data. They're pollinating.
Okay, so in the beehive, when they fly back, what is the beehive? What is the physical beehive?
The physical beehive would be an edge for them. Or it's their data center, basically. So it's the central point of all their processing. We might call it an edge, but it really is their data center, in a sense, where all the activities are happening.
I don't actually got it, but I say got it.
Yeah, no, I made it all up anyway. So
okay. We'll have to talk more about that. Kevin?
I tend to be more with the physical description in terms of being much closer to end users and end user applications. And a lot of that ties back to, well, I understand the software logical aspect of it. The hardware piece, there's fundamentals about moving atoms and bits and things like that that drive the need for the latency as well as the physical infrastructure associated with bandwidth that forces that edge to be something that's really co-located with where customers are generating and making decisions around data.
Just one comment back, and you hit on it with communications. The communications is a key enabler for edge, right? And so if I want to have this exchange of information, the ability to get that data moved in a rapid form is critical. And whether that means I move it back to just co-located area or farther, it makes a difference.
So I'm gonna try and unify this through the synthesis that I've just done on all of these answers. First off, I want to thank all the panelists. I want to thank all the questions. If I were to consolidate and try and unify this, would you guys then say we've got a little work to do on the taxonomy of the edge, but we can agree the edge is a gradient that should standardize potentially on interfaces, but differentiate on experiences? Mm-hmm. Awesome.
Well
you guys have been a great panelist. Thank you very much. Thank you to you. Have an awesome show, everybody.